All right, welcome back. So before we get started with example 3, let's go ahead and look at this helpful hint. So what this says is work backwards when planning a proof to show that segment ED is parallel to GF. So saying, look, okay, so if you're trying to prove that two lines are parallel, it's saying work backwards. So how it's saying you work backwards is you look for a pair of angles that are congruent, and then if you find those, right, you might be able to say that those two angles are congruent and then say that the lines are parallel because of the converse of, alternate interior angles or alternate exterior angles or course the converse of corresponding angles postulate. You know what I mean? Any of those things can prove that two lines are parallel. So look for a pair of angles that are congruent, and then if you find those pair of angles, then look for triangles that contain these angles, right? And so that is a way to kind of work backwards in order to do something. So just a helpful hint, something to think about. So let's look at this example 3. So it says, using CPCTC in a proof. So we have this figure here. It looks like a quadrilateral, right? Four-sided figure, but I also see that it's made up of two triangles. Okay, so let's see what we're given. We are given that NO is parallel to MP. Okay, so NO is parallel to MP. So what does that mean when we're given that information? Like, what is the purpose? So whenever they give you something, it's like a clue, right? That clue is going to lead us to something. What do you think that clue of these two lines being parallel could be? Like, we don't know, but I always like to just kind of like think about it. They gave me this. Why did they give me that? And kind of just kind of brainstorm and come up with some different ideas. They may be right, they may be wrong, but I just want to get my brain thinking. So when it comes to the proof, I'm just thinking about things, right? So what do we see? These two lines are parallel. We could have a transversal, right? And so we could say that maybe these two angles are congruent by the alternate interior angles theorem. This could be a transversal. This could be a transversal. There could be a variety of things. If I had to bet on it, I bet you money it'd probably be this transversal here that we would be using. But so those two lines being parallel and having a transversal probably is for the point of saying that two angles are congruent. And if you see, there's an angle here and there's an angle there. One's in this triangle and one's in that triangle. Okay, so that might be something. What else? It says angle N is congruent to angle P. Okay, that's another given piece of information. All right. So what are we supposed to prove? We're supposed to prove that MN is parallel to OP. We need to prove that these two lines are parallel. Now, how would we prove that those two lines are parallel? Well, probably by maybe using one of, a transversal and having two angles and saying, finding those angles are congruent, right? And if those two angles are congruent, if they're like alternate interior angles, then you could say that those two lines are parallel by the converse of the alternate interior angles theorem. That could be a direction, right? So we always want to think, right? These are little puzzles, and we got to kind of open up the door of these puzzles. So we're always just trying to think about different ways on how these things might be solved. Okay, so that's just a possibility. We may be going down that route to determine this, okay? So let's go ahead and just look at what we have, all right? So what do we have? We have that this angle is congruent. We have these lines are parallel. So those lines being parallel, let's say we take a look at this transversal here. If we extend those lines out, right, I always like to extend them, and we draw that transversal, what we see is that these two angles right here would be those alternate interior angles. So we could say that those angles would end up being congruent, right, by just the alternate interior angles theorem. So we'd have this angle, we'd have this angle. What else? Do you see anything else? What about this side? They share this side, right? So that means it's congruent by the reflexive property of congruence. So that side's congruent. Okay, so what could we say about these two triangles here? Well, could we say they're congruent? Well, we could because of, we have an angle, and a side. And this is a 1 angle goes to a 2 angle, then a side. And this is a 1 goes to a 2 and a side, so angle, angle, side. So we can say that these two triangles are congruent because of angle, angle, side, right? Okay, so we could do that. That's something we could do, but right, we want to figure out that MN is parallel to OP. So to have these be parallel, what angle do I need to be congruent in order to do the converse of, so let's see here. So if I need these to be parallel, so we're going to kind of whack backwards. Work backwards. This is probably going to be my transversal, right? And so the angles that I would need to be congruent would be this one right here and this one right there. If we could prove that those angles are congruent, those are the alternate interior angles, then we could prove that these are parallel by the converse of the alternate interior angles. Okay, so right now we don't have that, but we did figure out that we can show that these two triangles are congruent, right? So that would kind of be a CPCTC thing, right? Because we're using CPCTC. I actually see another way we wouldn't even have to do it to show that those two angles are congruent. But I'll say that. Can you think of it, what it would be? It's actually pretty easy. If we prove this angle is congruent and that angle is congruent by the third angles theorem, we could just say that those two angles are congruent, and then boom, those lines are parallel, boom. But this wants us to use CPCTC, okay? So that way that I just explained, that would be, we wouldn't even have to go through the whole angle, side, or CPCTC, right? Just this angle is congruent. This angle is congruent because of those lines are parallel. These lines are parallel, alternate interior angles theorem, right? And then we could just say, boom, third angles theorem. These two angles are congruent. Therefore, those lines are parallel by the converse of the alternate interior angles theorem. So that would be a way to prove it. However, this section is asking us to use CPCTC, so that's the direction what we need to do. So in order to use CPCTC, we have to show that two triangles are congruent, okay? So cheat rule, need 3 pieces of information. So what do we have? NP, okay, these are parallel, which means those are congruent, and then we have the reflexive property of congruence here. So angle, angle, side, angle, angle, side. So we can say that these two triangles are congruent because of angle, angle, side, and then we would just have to show that these are corresponding parts, and they would because it's the third angle, right? So it's the only one left. So we know that those two are going to be congruent because of CPCTC. Because those are congruent angles, then we could say that these are parallel because of the converse of alternate interior angles theorem. Whew! That was a lot. Okay. Let's go ahead and write it all down. So the first thing I'm going to do, I'm going to go here for this NO is parallel to NP. NO is parallel to MP. Okay. That's just given. Right? And because of that given information, we can say that these two angles are congruent. So what is that, an O? NOM, angle NOM is congruent to angle PMO because of the alternate interior angles theorem. Okay. So we have that one. Right, so that's it. Now we need this, right? So angle N is congruent to angle P. That's just given. Okay, and then what was the other thing? Oh, right. MO is congruent to MO because of the, what is it, the reflexive. We use this one so much. Remember when we like learned it? And, like I remember when I learned it, like what is the point of this? This is so obvious. This is so stupid. But it's like we use this reflexive property of congruence so much. It's just kind of crazy. It's kind of clutch, reflexive property of congruence. Okay, so there we have it. We have our angle side, angle side. So now we can just go ahead and write that those two triangles are congruent. So this is really important, right? How we write this. So I think I'm going to start with N. So triangle N. This is a 1, and then I'm going to go to a 2. So it's going to be NOM. NOM is congruent to, okay, so N. I'm going to start, this is a 1, so I have to start here because they're the same. So P, triangle P, and then it's going to a 2. So PM, PMO, okay. Yeah, and that is because of angle side, the reason. All right, cool. So now we use those 3 pieces of information. This statement unlocks the door to the other 3 pieces of information, which would be this angle and this angle, right? Being congruent, which is what we need. So we're going to say angle NMO is congruent to angle POM because of the alternate, no, not because of that, because of CPCTC. Sorry about that, right? And if you look here, angle M and angle O, angle M in this triangle is the third, it's right, first, second, third, and O is first, second, third here. So those are the same, right? Okay, and then, okay, CPCTC. Now we know that those 2 angles are congruent. We can say that these lines are parallel. So I'm making a 7. Line MN is parallel to line OP because of the converse of the alternate interior angles theorem. All right, that's it for Check It Out Example 3. Let's go ahead and look at Check It Out Example 4. No, not Check It Out Example 4. I'm sorry. Check It Out Example 3, okay? We're going to do one more. Okay. Okay, so what do we have here? We have this lovely figure. Okay, it looks like a quadrilateral. We have some diagonals going, but it could be, you know, those could be transversals. Who knows? We have a ton of triangles. So here's one, there's another one, there's another one. It could be like this, it could be like this, it could be like this, it could be like this. There's a lot going on in this picture. And then it's not labeled. I don't know, we're gonna have to fix that. So this says, what does it say? It says J is the midpoint of KM. So J is the midpoint of KM. So this is probably a K. So go ahead and write that in. I'm gonna write in with black. Sorry about that. I don't know why it's not there. Okay, so this is KM and NL. So this is L. That is it. That's all the information. But what does that mean? J is the midpoint of KM. So that means it's a midpoint. That means this is congruent to that. So KJ is congruent to JM. And what else? J is the midpoint of NL. So that means that these 2 sides are congruent as well. What we need to prove is that KL is parallel to MN. So let's think about this. How would we do that? We want to prove. So let's work backwards, right? So how do you prove something is parallel? By showing, you could show that 2 angles are congruent, and then by the converse, right? Then you could prove that those angles are congruent. So is there a pair of angles that we could do that with? So let's see if these are okay, we have these transversals. So if I was kind of going to extend that a bit and extend that a bit, it would be, this angle here, and this angle here would have to be congruent. And if we could determine that those two angles are congruent, those are alternate interior angles. If we could prove that those alternate interior angles are congruent, then we could state that KL is parallel to MN by the converse of the alternate interior angles theorem. Okay, so the thing is how can we prove that those two are congruent with just this information we have here? What do you guys think? Do you see anything? So that's it for given information. We have this side is congruent to that side, this side is congruent to this side. And I think we want to stay, I think what we're going to want to use is these triangles here, because these triangles include these two angles. So see how there's 1, 2, 3, 4 triangles, and then there's a lot others more. But because we want to find this triangle, this angle, these two triangles here, the top and the bottom, both include that one. So I think that that's where we're going to want to focus. Do you guys see anything? Do you guys see vertical angles right here? So look, the vertical angles theorem means that this angle is congruent to this angle. And then what do we have? Side angle side, side angle side. These are some sassy triangles. And because of side angle side, that would mean these two triangles are congruent. Therefore, we could use CPCTC. And if these two angles here were corresponding angles, they would be congruent. And if they're congruent, then we could say that those two lines are parallel. Make sense? All right, cool. Let's go ahead and write it up. So first thing is just writing down all that given information. Okay, sorry, I had to take a little drink. All right, so we have J is the midpoint of KM and NL. And that's just given, right? Now, because of that given information, we can say a whole lot. We can say KJ is congruent to JM, and KJ is congruent to JM, and NJ is congruent to JL. And that is because of, do you know it? Definition of a midpoint. Okay. Then what? This angle here. So let's go ahead and say KJL. KJL is congruent to NJM because of the vertical angles theorem. And there we have it. We have our side angle side. So now we just need to write the angles, the triangles correctly. So I think I'm going to start with J here because we know that those are congruent angles because of the vertical angles theorem. So I'm going to say triangle J, and then I'm going to go in the direction of the side that has a 2. But you could go this direction. It doesn't matter. It just, you have to write it correctly. So I'm going to go towards the 2. So it's going to be JLK is congruent to triangle J, right? And then I'm going to go in the direction of the 2, which would be to N. So JNM. Okay, that would be, what would that be? That would be, side angle side. Those are congruent because of side angle side. They're sassy. Okay, so then we want to look. We need these two angles, right? So the one that has the L and the N. So the L is the second letter here, and so is the N. So that's great. We know that they are congruent angles because of CPCTC. So, wow, I just said that super fast. I'm kind of impressed with myself, you know. Okay, okay, so we have KLJ, angle KLJ is congruent to angle, this one, MNJ. Because of the, CPCTC. CPCTC, yes. And because those two angles are congruent, I'm going to make them like that. We can say that these two lines, KL and MN, are parallel because of the converse of the alternate interior angles theorem. All right, that's it for example 3. Great job, and I'll see you back in a little bit for example 4.